Hello, my name is Darren Thomas and I am the Director of Education and Research Techniques. In this video, we're going to learn how to calculate the area of a sector of a circle. So let's go ahead and get started. Now, in order to have success calculating the area of a circle, there's a few things that we have to kind of cover to make this as clear as possible, if you will. So here's my circle right here. And there are several pieces of information you need in order to be successful. So to do this, you have to know, of course, what the radius is. This will help. Or at least some of this information. Some of this you can figure out on your own. So, whoa. Oh, brother. Okay, I got it. Like this. And then we want this. Like so. And then no, we don't want that. Then we want this. All right, there we go. Okay, so you need to know some of the following. You got to know some of this information. So you got to know, maybe you know this. Let me make that a bit bigger. So this is going to be our theta right here, and then of course radius, and then of course that's pretty much it. Radius and theta, excuse me. And so the formula for calculating this area, and what we mean by area is the section between the two sides, between the initial side and the terminal side. It's just going to be as follows. It's going to be the area is going to equal 1/2 theta times r squared. That's pretty much how it's going to work. So to have success, this is basic algebra, but to make life simple, if you know at least two of these three things, you'll be okay. Of course, you could probably figure out ways to get it done with or without that information. And so generally you have the two steps here. Now, when we're dealing with the area, we want to convert it to radians or make it unitless, if you will. So first you got to do some conversion normally. And then after that, you have to actually use the equation that is listed above. So let's go ahead and look at an example here. So let's draw a circle again. This is going to be fun, like always. So here's our circle. All right, and then we're going to have our information here. I'll make it a little bit wider. Yeah, that's good. This is obviously not drawn to scale. Okay, so here's what we know. We know the following information. So we know that the radius of this circle right here that we're going to use is 20. It could be meters, centimeters, it doesn't really matter. And we also know that the degrees is 60 degrees. And so using this information right here, we want to find the area, or we just call it A for short. What is this area inside this particular sector right here? So to do this, we just first convert. So I have to take my 60 degrees and convert them to radians. So I just take 60, multiply by pi over 180. And so I get 60 pi over 180. And that reduces down to pi over 3, because you divide both these guys here by 60, right? Like so. So I got pi over 3. So I'm halfway done. Now the next thing I have to do is I have to take my actual formula. So I do 1/2 times pi over 3 times 20 squared is going to give me my area, my A, if you will. And so when you multiply all this out, we're going to make life simple for you. You can do it on your own time, of course. But the actual answer is going to be 209.43. This is the answer. And that's how you would get the answer. So, of course, 20 squared is going to be 400. 1/2 over pi over 3 is going to be pi over 6. You multiply pi over 6 by 400. Okay, you get 400 pi over 6. It's not that deep. You can calculate on your own. And this is kind of how it works out. So this area right here is going to be, 209.43, whatever units you're using at the time. Let's do one more. And this is more of a word problem. And this is kind of what's, that's not what I want. This is kind of what's happening here. So you have a field, and for whatever reason it's a circle. Don't ask me why it's a circle. Let's just keep going with the illustration here. And so there are restrictions on how much of the field you can cut in a day or whatever. So let's just say they put a restriction at, or maybe it's like a forest or something. You can only, actually I think in the original problem it was water. You can only water 150,000, an area of 150,000 of the circle. And so you need to figure out is, okay, if I can only water 150,000 of this circle, what angle do I need to set the sprinkler to? Oh, whoops. What angle do I need to set the sprinkler to in order to be able to water the grass or water whatever I'm watering? So we want to figure out this. So we want to figure out theta this time. And just so you know, the radius is 400, and the area of the sector is going to be 150,000. 1, 2, 3. So in this particular example, we don't quite need to convert because we're already starting with something that's kind of unitless. So we're just going to plug in our information as we know it. So we know that our area is 150,000. 1, 2, 3. And we also know it's going to be times 1/2, obviously. And we don't know theta. That's what we're trying to figure out. But we do know the radius, so that's going to be 400 squared. So here we go. If we do 400 squared, that's going to be 160,000. So 160, 1, 2, 3. Like that. Is that correct? Yeah, 4 zeros. Yes. But that's going to be times 1/2 again. And we're going to have our theta also. And so 1/2 times 160,000 is going to be 80,000. So we're just kind of wrapping this up here pretty quick. So now we have 80,000. 1, 2, 3. Theta equals the 150,000. 1, 2, 3, 4. Okay, like so. So now this is just basic algebra. We divide both sides by 80,000. 2, 3, 4. Probably could have just removed the zeros, but hey, 2, 3, 4. And so we end up with an answer that is basically 1 point, let me put up in the top corner here, 1.875, I guess you could call this radians or whatever. And so this is not quite what we want. These are not degrees. We need to convert this answer here into degrees. So why don't we go ahead, I need a little bit more space here. So to do that, instead of going from degrees to radians, we're going for radians to degrees. So that's going to be 1.875, I believe, was the full answer, times 180 over pi. And that's going to equal 336 over pi. And if you actually get the actual answer by, using the calculator, 336 divided by pi, you'll get 107 degrees. That's the actual answer. So when they set the sprinkler, they need to set this theta here to 187 degrees. 107 degrees. And that will allow them to spray this area of 150,000 meters or centimeters or whatever it is, when you have a radius of 400. That's how it works. So you can see that, this could be a lot of fun, how to play with calculating the area of a sector. So let me go back and review, recap, and then wrap up the video. So in this video, we talked about how to find the area of a sector of a circle. And so the formula is, you can see as follows: area equals 1/2 times theta times r squared. And normally you have to do a conversion where you take it from degrees normally to radians, or sometimes even vice versa. And after that, you use the actual equation. And so here on the next slide, we had our first example here. We had a radius of 20. We had a theta of 60, and we wanted to find the area. And so by just following the steps, first we converted from degrees to radians. That got pi over 3. And then we just plug in the information into the actual equation, and we got the answer there. In this next one, it was a little bit different in that this time we knew the area, but we were trying to figure out what is theta. But again, it's the same idea. You plug in the information you have, and then you solve for what you do not have. And so by going through the process, we found out that we had 1.875 radians. That's what we have. And then we had to convert the radians into degrees. So this time we kind of did things in the opposite direction. First we used the equation, then we converted. Whereas with the first example, we converted, then we used the equation. So you just have to keep in mind what is your purpose and goal to determine what step to take first. So I hope that this video was useful for you and that you understood what we were talking about and how things were going. My name is Derek Thomas. I am the Director of Education and Research Techniques. Take care.